Okay, so today we are going to finish up Chapter 12, Section 5 notes. Today we're going to focus on combinations. So I'm going to go to the slide where the combinations start. And here it is. So first we're going to define what a combination is. And a combination is a selection of objects in which order is not important. It's used when drawing for identical prizes or especially when order does not matter. That's the main idea behind this. So let's say you were reaching into a bag and you were trying to pull out, say, marbles. It doesn't matter the order you pull them. Let's say you had a bag of marbles, and in the bag of marbles, let's say it had red marble, blue marbles, and green marbles. If it says order matters, where you have to take out a marble, look and see what you get, and then put it back. Here, if you're just grabbing two random marbles out of the bag, it doesn't matter if you order it as red and then blue, or blue and red if that's what you pull out of the bag. These two combinations are the same thing. If it were a permutation, you would count those separately. So if you're just randomly grabbing something and you don't care the order, that's a combination. So here it wants us to count the combinations of two letters from the list. And just be careful, the D went down here to the bottom line. So it wants us to order two letters at a time from the letters A, B, C, and D. So just to show you how I can make my organized list without learning the formula or anything yet, I could put A and B together. I could also put A and C together. And then I can put A and D together. Then if I switch and now pick the B next. Now, if I list B and A, in the case of a permutation, this would be important. But order doesn't matter here, so I don't count this one because I've already included in my count pulling letters A and B out of, say, a bag or whatever. Then I could also put B with C. I haven't listed that yet. And then B with D. Now when I switch to starting to make my list with a C, I could put, if I try to put C with A, notice I've already listed it here, so I'm not going to count that one. And then if I try to put C with B, I've already also listed it right here. So again, I would not count this one. And then I can count C with D because I haven't listed that yet. Now, when I go to make my list of D with A, well, I already listed it here, so I don't count it. D with B, I've already listed it here, I don't count it. D with C, I've already listed it here, I don't count it. So the only possible combinations that I'm worried about listing are going to be AB, AC, AD, all of these, and there's a total of 6 combinations. If it were permutations, then there would have been 12. So if it said permutations, where order matters, there would be 12. So there's always going to be fewer combinations than permutations because I'm not interested in the order that I'm placing those letters. Now we're going to see the formula. So this is the combinations formula. So it's the number of combinations where n objects are taken r at a time, where r is going to be less than n will always be the bigger number. Now, if you remember your formula for permutations, that formula was P and then it has an n and an r. It was n factorial over n minus r exclamation point. The difference between the combination and the permutation, they're just adding r factorial to the denominator. Because remember, there's fewer combinations. So we're dividing by a number, and that's why we're going to end up with fewer combinations than permutations. So it's essentially the same formula. The only difference is we add this R exclamation point or R factorial and then change this to a capital C. That's the only change in the formula. So let's go ahead and try to use this formula now. So now here it says, you order a sandwich at a restaurant. You can choose 3 side dishes from a list of 8. How many combinations of side dishes are possible? So here, when you're choosing your side dish, the order doesn't matter. So it doesn't matter if I choose a salad, French fries, or mac and cheese. That order of my side dishes doesn't matter when I'm placing my order. I'm still going to get the same meal. So this would be a combination. So again, the n value is the greater number. So we're going to be doing combination of 8 things taken 3 at a time. So again, let me just write down the formula. N factorial, n minus r factorial times r factorial. So let's fill in our numbers. So n is 8, r is 3. So we'll fill it in. So combination, 8 objects taken 3 at a time, 8 exclamation point over 8 minus 3 times 3 exclamation point. And again, there is a button on your calculator, but I would like to see the setup when you do your work of how you're plugging it into the formula. So then I'm going to go ahead and subtract what's in the parentheses. Now, do not multiply 5 and 3. We actually have to expand these factorials out. So the way that I'm going to do it is I'm going to go ahead and expand the top down to the number that's the bigger one in the denominator. So 6, and then I'm going to stop at 5 exclamation point because that's the bigger factorial here. Now, I'm going to show you the other way that we could also do it. So then 5 factorial. Then for this one, I'm going to expand it because I don't have anything to cancel with it. So then now what I can do is cancel the 5s. And then if you want, you can either multiply 8, 7, 6 and then divide it by 3, 2, 1. Or if you want to simplify before you multiply, I could do 3 times 2 is 6 and I could get rid of that. And then I'm just left with 8 times 7 and then 1 on the bottom. So 56 different combinations of choosing 3 sides out of 8. Now, if this confuses you with canceling this, you could also do this. And let me write it all out. You can also do 8, 7, 6 and write all the numbers all the way out. And then here again, 5, 4, 3, 2, 1, and then put 3, 2, 1 for the 3 exclamation point. So this is here, and this is here. And again, if you want to look for things that match in the top, that match in the bottom, the 5, 4, 3, 2, 1, I can get rid of that. And then if you choose to do the 3 and the 2, you can. If not, just multiply and then divide. So I always like, because sometimes we give this quiz when everybody is in person without a calculator. So again, cross that off and you're just left with 56. So if you happen to see this on a standardized test, an SAT or an ACT, you might get a question like this without a calculator. So be able to do this. Pretty good on that example? Okay. So for example 7, it says a yearbook editor has selected 14 photos, including one of you and one of your friend, to use as a collage for the yearbook. The photos are placed at random. There is room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the two placed at the top of the page. So it doesn't matter, just that you're both at the top. So again, we need to first find the number of possible outcomes of choosing two photos out of 14. So we're going to do the combination. 14 photos total, and we're choosing 2 out of them. So we're going to do 14 exclamation point over 14 minus 2 exclamation point times 2 exclamation point. I'm going to simplify. 14 exclamation point, 12 exclamation point times 2. Do not multiply 12 and 2 and get 24. We just have to simplify this down individually. So again, I'm going to go ahead and do 14 times 13 times 12. I'm going to go down to as far as the bigger one in the denominator and then write that bigger one. So this 12 goes here, but then I'm going to expand the 2 and make it 2 times 1. So now the 12s will cancel. And if you want to simplify, like I'd simplify 14 and 2, and I can change this to a 7, and then just leave that as a 1. And then 7 times 13 is 91 over 1, or 91. So this is going to be the total combinations of pulling 2 photos or picking 2 photos out of 14. But the question asks for probability. And there is only one way of pulling my picture and my friends out of that group of 14 and placing it at the top. So the probability that your photo and your friends are chosen is going to be 1 over 91, because there's only one way to pull my picture and my friend's picture out and place it at the top.
How did you find that?
How did I find what?
The probability.
The probability, because it's always favorable over total. So the total arrangements of 2 pictures chosen out of 14 is 91. And then there's only one combination out of that whole list of 14 that would be me and my friend. Yes. So for example 8, it says your teacher randomly chooses 2 out of 18 students to give an impromptu debate on the freedom of press in high school newspapers. What is the probability that the teacher chooses you and your best friend? So again, for probability, there's only one way of choosing me and my friend out of all the different combinations, but I need to find the total number of combinations of picking 2 students at a time out of the 18. So that's going to be a combination, 18 and 2. So I need to find the total. So 18 exclamation point over 18 minus 2 times 2 exclamation point, 18 factorial, 16 factorial, 2 factorial, and now let me expand that. So I'm going to take the 18 down to 16. I'm going to write the 16 right here, and then I'm going to expand the 2. So the 2 becomes this. The 16 I placed here, and they cancel. And now if you want to simplify the 18 and the 2, you can go ahead and make that a 9. And then you're just left with 9 times 17, which is 153 over 1. And again, that's the total number of outcomes of choosing 2 students out of 18, and then the probability that the teacher chooses you and your friend, there's only one favorable way or outcome of choosing you and your friend out of the total 153 combinations. The hardest part of this lesson, now that we've learned both permutations and combinations, is reading the word problem and to decide which formula to use. So if order is important, then you use permutations. If order is not important, then it's a combination. So on the test, I will not tell you what formula to use for the word problems. Now, if it's like example 9, and it's just the little symbol, these are super easy questions. You just take the two numbers and plug them into the formula. So here it wants to know how many combinations of choosing 8 objects out of 10 can you make. So again, the bigger number, the 10 is the n. So 10 factorial divided by 10 minus 8 factorial times 8 factorial. So 10 factorial over 2 times 8. Again, I'm going to break down the 10 until I get to the bigger number, which is 8. So 10 times 9, and I'll leave the 8 as the exclamation point. This 8's right under it, and then I'll expand the 2. And then the 8's are going to cancel. And then if you want, you can also simplify the 10 and the 2. And then you're just left with 5 times 9, and the number of combinations is 45. For the last one, it's going to be kind of long because it's 24. So you're going to do 24 factorial divided by 24 minus 10 times 10 factorial. 24 factorial over 14 factorial times 10 factorial. And now I'm going to expand it out. So for the top, I'm going to take 24 all the way down until it gets to 14. So 23, 22, 21, 20, 19, 18, 17, 16, 15, 14. And this is an exclamation point. I'll write that one right underneath it. So these cancel. But then I've got to also expand out the 10. So then that becomes 10, 9, 8, 7, 6, not 8, 6, 5, 4, 3, 2, 1. Now, someone in my C period class, she was trying to do this the long way on her calculator instead of simplifying before she multiplied. She found that when she did this, she needed to use parentheses. So this is why it's really important that you play with the calculator that you're going to use for the test. So when she did this, she multiplied all of this, the numerator, hit enter. She got her answer. It was scientific notation. It was like 7.11 times 10 to something. And then she did the denominator, but she didn't use parentheses and she was getting the wrong answer. So when you do this, figure out if you need parentheses or not. The correct answer after you do all this multiplication and division should be 1,961,256. Should be your final answer or the total number of combinations. Now again, remember there are the buttons on your calculator. If you find the PRB button or if you have the graphing calculator, it's the math button. But what I'd like to see is how you've put it into the formula when you take this test. I'd like to see when you put it in and give me this part of it. But if you know where this C button is with the N and the R, then you can use that button after you set it up for me. So again, make sure that you're knowing if you need to use parentheses or not. And that is the end of the notes for 10-5 or 12-5. So again, I can't stress enough, practice with the calculator that you are planning on using for the test. Okay?
Miss Corey,
Yes.
can you go back to the slide before the one you just finished?
Okay.